at. Any questions on this review? Let me know what questions you want to go over. So Unit 9 is just your factoring and your dividing polynomials. Number 3. The biggest thing with this will you being able to recognize what type of factoring you need and being able to do that. So number 3, we have 4 terms. 4 terms is your grouping, where we split that down the middle. And then find the GCF. What could we divide out of both of those first two? X squared. And then what would be left? X plus 2y. And then same thing for the last two. What could we divide out of those two? Negative 2 works is the highest. Negative 4. Today, leaving X, not minus, but plus 2y. Remember that your goal with grouping, factoring by grouping, is that your insides should be the same. And if those are the same, you could rewrite this as x squared minus 4, whatever's on the outside, whatever you factored out. And then whatever's on the inside, you would just write that once. But you also need to double check that you can't factor either one again. This one can be factored again using difference of squares. So instead of having just 2 factors, it's going to have 3 factors. Because we're going to split the x squared minus 4 into these two. We're thinking what times what gives us x squared? X times x, and what times what would give us 4? 2 and 2, and put a plus and minus. Now, your Desmos tricks still work on your calculator. So, like, you could, not for this one, but in general, if it was a trinomial, a regular trinomial, you could put that into your y equals, and then put in your factors and see if they cross at the x-axis. But that only works for your trinomials, not this one. Questions on that one? Other questions on this page? 10. So I will say in that we did GCF, we did grouping, we did difference of squares, so that was 3 different types. 10 is your A equals 1 trinomial, where you're looking for 2 numbers that multiply to be negative 16 and add to be negative 6. What are some factors of 16? 8 and 2. And would that work? Yes, if you made one of them negative, which one would be the negative? Negative 8. So then we're going to have 2 factors, 2 sets of parentheses, whatever the variable is, put that first. And then your 2 numbers, put those in. K minus 8, K plus 2. Other questions? Let's finish factoring and then we'll go on to that one. So are there any other questions with factoring that we want to do before we jump to dividing? So 20. You said 2 zeros. So on the back. Remember, if you have a binomial, there are only 2 methods you can use, DCF or difference of squares. Which one could we use here? So they're both perfect squares. Everything is a perfect square term. So if we were to split that, what times what would give us 100? What times what would give us 9y squared? 3y. Put a plus, put a minus. Doesn't matter which one comes first. The only factoring thing you haven't done is a doesn't equal 1. I would say find one of those just to make sure we're good with that. 21 is grouping, but we can still do that. So grouping, 4 terms. Split it down the middle. What's the DCF of the first 2?
5a.
5a, leaving a plus divided
2b.
2b. And then what can we divide out of the last 2? -3, leaving
a plus
a plus 2b. So that final answer would be 5a minus 3 and a plus 2b. Neither of those you could do anything else with, so that would be your final answer. Okay. Somewhere where you have space, I want you to write these problems down. If you want to do any of them, you can do those. If not, they will be for future contests. So somewhere in your notes, you may have already written these down, but just so you have them on your review. You can write down all 4, you can write down just a couple, write down at least 2 somewhere. And then there'll be 2 more. You write down the other 2, and then if we wanted to do any of those, we'll go back and do those. And then we'll start with the next piece. Let me go back to the other page so that you guys can write that, and we'll come back to that again. And then somewhere else where you have space, write these 2. Again, somewhere in your notes previously we did these, but just so you have a refresher. You shouldn't need that much space, so like at the top or at the bottom or a side. So we'll go back to the other page so that we can try the second one. If you see something like this, we want to get the fractions, we want to get rid of the fractions. We do that by multiplying the whole thing by whatever the denominator of the last fraction is. So everything by 36. That's going to change everything. So I know this would be 36w squared. I can multiply these in my calculator. -84. And then the 36 is here, which cancels, leaving 49. On my calculator, I can look and see if I have a GCF by going into math, going over to number, scrolling down to number 9, and then putting in the numbers 2 at a time, 36, 84, and then doing it again, but doing 84 and 49. And then if these two numbers are different, I would take the GCF of those two, but I know that those aren't going to have something in common, but I'll show you just so that we focus on this. Which means there's not a common GCF between all three. So then we would follow our A equals 1 steps by multiplying 36 and 49. Yes, it is a huge number. We need to find two numbers that multiply to be that, but add to be negative 4. And since I know 36 times 49 gave us that, and they would both need to be negative, I'm going to start there. That's negative 85, so it's close. So I know it's going to be between 36 and 49. So I'll try 37 and see if that works. No. 38. No. 39. No. Not 40. Not 41. But 42 works. And if I make them both negative, that would give me 84. So I would make this 4 terms by splitting the middle, rewriting that middle term into the two numbers I found. Then it's just factoring by grouping. Split the middle, find the GCF of the first two. What would that be? 6. Leaving
6.
-7. And then what would the last two, what would the GCF of the last two be?
42.
The GCF would be 7, negative 7. Leaving 6W minus, so our two answers would be 6w minus 7, and that would repeat. Weird 6. Or you could put 6w minus 7 squared. Yes.
42.
42 doesn't. 49 can't be divided by 42.
42.
That can't be the GCF. Because you can't divide 49 by 42. Okay. Did we want to see one of the other ones before we jump into dividing polynomials? See if you have a question on the second page. So your dividing polynomials is you're by a monomial and by a binomial. So you have to know how to do both. Three is not something you would see. You would see something more like these, because this is just using your x. So we're not going to do that. You could choose a different one.
14.
Alyssa, which one did you say?
14.
So with this, you could do this one of two ways. Either separate it or factor out the GCF. I'll do one way and one the other. If I wanted to separate this, I would just rewrite it with each term over the denominator. And then I would use my exponent rules to simplify both pieces. Actually dividing the numbers, so this would be positive 5. I'm subtracting my exponents, so x squared, y squared, minus. This would be negative 6. The x's would completely cancel, and this would be y to the 4th. And that would be your final answer. Questions there before I show you the factoring method? In 15, if I wanted to do the factoring method, I would look for what do these two have in common? What is that GCF? 5. And then how many A's, how many B's, how many C's? 1 A, 1 B, and C. Usually whatever the denominator is, but that's not always the case. So if I were to divide that out of the two terms, what's left here? A to the 6. B second, C, minus 1. All over that 5AC, ABC that was already there. And then you would cancel those, just leaving whatever's left. Or A to the 6, B squared, C minus 1. So you can do it either way. By using the factoring method or by separating. Other questions on this page or the back of this page before we go on to the binomials? Divided by a binomial.
We do the 21.
Say it. 21. By separating or by factoring? Choose. Okay. So by factoring, what is the GCF of each of these terms?
3.
3 what else? C to what power?
3rd.
Mm-hmm.
B to the 7.
B to the 7. Okay. We divide that out of each piece. What's left? Squared. Yeah. D to the squared minus. I'm gonna rewrite this. this is a case where you're going to have something left over. It's not exactly the same. Which, in this case, it may have been easier to separate, but it's okay. So, still divide these. The 3's go away. We have 1c. We have d to the 5th. And then we have to factor that back in. So multiply the c, d to the 5th to everything. C to the 3rd, 10c to the 3rd, d to the 7th, minus 4c d to the 6th, plus cd to the 5th, is what this is again. If you had separated it, instead of factoring out, you would have got the same thing, and wouldn't have had to multiply it back. But anytime you have something left, you have to multiply that back. Other questions for dividing polynomials by a monomial? Questions on the binomial section? Yeah. 8. Number 8, dividing polynomials by a binomial. We have to first factor the numerator. So in all cases, check for GCF. Does this one have one? No. So then we're going to factor using a equals 1. Multiply 3 and negative 16. And find two factors that multiply by negative 18 but add to be negative 7. You can list out all the factors or the one that works. What are some factors of 18?
2.
2 and 9. Would that work?
Yes.
If we made the non-negative, yes. So then rewrite this into 4 terms. 3y squared plus 2y minus 9y minus 6. If you wanted to switch those, you could. Make sure you're not losing your denominator. And then split that down the middle. What would the GCF of these first two be? Y, just y. Unless you switched it, then it would be 3y. So if I divide y out of my 2, what would be left? Less. Bless you. What would be left here?
3y
3y
plus 0.
plus 2. And then what can we divide out of these two? Negative 3. Leaving 3y plus 2. And then we can rewrite our factors as final factors. Y minus 3 and 3y plus 2 all over our denominator, and then cancel out like factors. So that our final answer is 3y. So in your calculator, if you change all of your y's to x's and put that in to your y equals, it would give you a line. Now, you wouldn't be able to count it as easily, but you could look at the table and find that slope and find the y-intercept. Questions on that one? Other questions in the binomial section? This is going to be similar to the last one you did. Does this have a GCF? If you want to go ahead and rewrite it, I will do that when I split the terms. So this is still at 8, doesn't equal 1. Find two numbers that multiply to be negative 72, but add to be negative 1. And an 8. And the 9 would be negative. We have 6n squared minus 9n plus 8n minus 12 all over 3n plus 4. And then keep going. Split the middle. What could we divide out of these first two? 3n. Leaving 2n minus 3. What can we divide out of the last two? 4 plus 4, leaving 2n minus 3. And then we have 3n plus 4 and 2n minus 3. All over 3n plus 4, leaving 2n minus as our final answer. Other questions? If no other questions, I would say keep practicing in this. Bring me any questions you have. If you haven't done the Delta math on this, definitely go back and do that, as it will be good practice and those were formatives on the upcoming tests before your test on Monday.